Welcome. I'm John Grace, and I want to thank you for taking the time to learn more about what we're doing at Enth. I'm presenting to you today because I'm the guy that built Enth. Before we get started, I should tell you that I began my career doing data science as a graduate student at the University of Chicago. Rather quickly, I found I was spending too much time on data and not enough on science. Enth is my attempt to radically alter that condition. This video, Enth, Apache Spark, and Graph Databases, is one of a series of videos in which we introduce Enth and demonstrate Enth working with Apache Spark, with Spark's graph frames, demonstrate live joins between private ERP data and public data, and maybe I'll connect an Amazon Echo to Enth. I guess I have a lot to do, so let's get started. Up on the screen, we're looking at a new type of analytic data science data access tool called Zeppelin. Zeppelin is a web-based notebook that enables interactive data analytics. Zeppelin is built around Spark, and both Spark and Zeppelin are projects in the Apache open source community. Spark is a fast general engine for big data processing, but Spark has no data. We're still required to write code to load data to make Spark work. Well, Enth does three interesting things. 1. Enth crawls networks, including private networks, looking for data, structured, open, elastic, relational, text. Enth doesn't download this data. Instead, Enth indexes this data. 2. Enth uses these indexes as part of a machine learning process in which Enth creates an awareness of data. And 3, Enth uses this awareness of data to orchestrate the acquisition and transformation of data into Spark. In other words, Enth tells Spark where to find specific data and what to do with it. Enth is not a repository, warehouse, or lake for data. Enth is an n-dimensional awareness of data. As I mentioned, Zeppelin is a web-based notebook. I'm using a standard version 0.7. We use the windows or paragraphs presented here to interact with our data. Within Zeppelin, I'm using Enth Spark, a product we built that connects an Enth instance to a Spark instance. I'm going to start by importing a few Enth Spark libraries that I'll need. I'm going to go ahead and connect to Enth. Now that we're connected, we're ready to search. And yes, I said search. We're going to search the internet for our data. I've nested several calls to Enth Spark. For a more detailed explanation of these calls, please refer to the Enth Spark introduction video. I'm searching for Horton, year, and team because I know the results are going to be pretty cool. Once I get my Enth data frames array, I can use get Enth graph frame to get an Enth graph frame object. My Enth graph frame object is built with all the elements of the Enth data frames array. The Enth graph frame object encapsulates Spark's graph frame, and graph frame is basically a graph database. Finally, a call to get D3 allows me to visualize my graph data. And as you can see, Enth responded a little too quickly for my video, but this is a little glimpse into what I get to do for a living. What we're looking at is a D3 force-directed graph. The code to generate the D3 image is created by Enth Spark. The clumps generally come from specific or related data sources. Within these clumps, you can begin to recognize individual records. Here we have content from CDPH environmental permits. At some point, a Mr. Horton applied for an environmental permit. We can find Mr. Horton. There he is, Mr. Horton. This more complex cluster is from the NPPE, or the National Plan and Provider Enumeration System. The NPPE are unique identifiers for healthcare providers, basically doctors and hospitals, and healthcare plans or insurers. The more common elements in the middle are plans, like Medicare, other, Medicare, and Medicaid. The outer points are generally doctors. Dr. Karen Horton. My real interest here is that this search yields a bunch of intersecting triangles. Each triangle represents a player, a team, and a year. Check out this single triangle down here. This triangle represents Wes Horton, who played only 1 year for the Carolina Panthers, 2013. This triangle has got 2 intersecting triangles. And this triangle is for Jason Horton, who played for the Packers in 2004 and in 2005. My real interest here is in a Detroit Tiger, Willie Horton. Willie Horton was the Detroit Tiger for many years, and as such, he's a very popular vertex in this graph. The reason the 2 rather complicated triangle clusters are not connected is they don't have any intersections between players, years, or team. What's interesting here is that these triangles form the basis of Facebook and LinkedIn. Facebook and LinkedIn use graph databases to store people, their relationships, and interests. So we've just created a social network without the social part. There are many features that are built in to Spark's graph frames. Pagerank, I'm sure you're aware of. Pagerank is a calculation to determine popularity within a universe. Pagerank is commonly used by internet search providers to score results. As you can see, Medicare and Medicaid are some of the most popular data points in our search results. But the former Tiger Willie Horton is in the top 6. Let me close this one. Connected components is also a very interesting part of Spark's graph frames. Connected components numerically identifies clusters of data. I mentioned Wes Horton and Jason Horton earlier. As you can see, these clusters are easily identifiable. Wes Horton, 2013 Panthers, he's been identified as cluster 239. Jason Horton played for the Packers in 2004 and 2005, has been identified as cluster 197. So connected components allows us to identify different clusters of data. The results for both PageRank and connected components are Spark data frames, and as such are accessible for other Spark processes. Let me go ahead and quickly run another search. I want to see who played baseball in 1968 by team. With this result, I'm going to iterate through my results and eliminate some sources I may not want to see. I want to look just at baseball stats. Okay, let's see what we have. Okay, I've asked for both the score and the schema. So the top 2 are hitting and pitching, and there's several other results with much lower scores. So I'm just going to add hitting and pitching into my results, and let's see what we get there. yeah, I still think this is pretty cool. What we have here is basically, I can get it to slow down for a second. We have Major League Baseball in this vertex for two sources, hitting and pitching. We have 1968, again for two sources, hitting and pitching. And they're at the center of our visualization here. I asked for team, and what we can see here is the teams are beginning to clump around in the outer areas. So here's the Baltimore Orioles. Here are the Reds. Here are the Red Sox. The players who played for those teams in 1968 are reorganizing themselves around the team. So here's Don Kessinger, John Stevenson. This is just a little example of some of the things, that we can do as far as building dynamic graph databases from public and private data. So using these nth graph frames, we can build custom databases merging almost any sources you can imagine. Well, I hope I showed you something interesting. If we piqued your interests, we do have other videos that you might enjoy. Links are provided at enth.com. If you're wondering if you can use Enth to access your data, the answer is yes. If you're wondering if you can use Enth to search your private data and public data, the answer is also yes. If you're wondering if you have to upload all your data to Enth, the answer is absolutely no. If you're wondering if you can use Enth to securely join private sales data to public weather or private customer data to public demographics data in real time, the answer is yes. And this, my friend, is the whole point of Enth. Let's work together to put science back in data science. Enth is delivered via Docker. Non-commercial or development use of Enth is generally free of charge. We look forward to hearing from you.